Hello everyone, welcome to our channel, the Digital Institute of Computing Technology. In this presentation, we will have discussion on the topic pointers in C programming language. What is a pointer variable? A variable that can hold a memory address is called as a pointer variable. Pointer variables can store memory addresses of other variables. We can have a pointer to an integer, pointer to a character, pointer to a float, pointer to a structure, a user-defined data type. As you are aware, RAM has the instruction and the data. The CPU fetches one instruction at a time and performs operation on the data based on the instruction. So both the data and the instruction has a memory address. That implies both variables in the program as well as the functions in the program will have a memory address. And additionally, in programming language like C, we can access the address of variables and functions using a pointer. The declaration statement data type star ptr declares a pointer that can point to a variable of a specific data type. Example, int star ptr, the declaration statement above initializes a pointer to a specific memory address or to a null to avoid uninitialized pointer issues. Now let's discuss some basic terms. Ampersand. It is an address of operator. It returns the memory address of a variable. Example, A is a variable of type integer with a value of 89 and pi pointer to an integer and has been initialized to the address of A. Dereference operator star used to access the value at the memory address stored in a pointer. Example, star pi assign 20. If pi holds the address of A, 89 will get modified to 20. Here, A represents the value stored in the memory location assigned to A, whereas ampersand A represents the address of the memory location. A is 89, whereas ampersand A is 200x, the memory address. Star pi is 89, whereas pi is 200x, the memory address of A. Ampersand pi is the address of pi, 2090x. Actually, 2090x is an address of a pointer because pi is a pointer. So this can also be called as a pointer to a pointer. Now, one important point to note here is that pointer to an integer can only store the address of an integer. We are assigning the address of A to pi because pi is a pointer to an integer. So it can only store the address of an integer, but cannot store the address of data types like character or float. We need to create a pointer variable of a specific type to store the address of that type. Let's consider this example. In this example, f is a variable of type float and pf is a pointer to float. C is a variable of type character and pc is a pointer to a character. P is a pointer to void, which can be typecasted as a pointer to any data type. Struct emp is a user-defined data type and emp is a variable of that type, and p is a pointer of type struct emp. Let's assume f has been initialized to value 701.55 and c has been initialized to value character x. Now when we display f, we will actually display 701.55, and when we display ampersand f, we will actually display the address of f, which is 2060x. Similarly, when we display C, we will actually display X, and when we display ampersand C, we will actually display the address of C, which is 2080X. Now let's try to access a list of a particular data type using a pointer variable. Let's access an array of integer using a pointer. In this example, num is an array of integers initialized with values 10, 20, 30, 40, and 50. Pi is a pointer to an integer and has been initialized with the base address of the integer array num. Initially, Pi points to the first element of the array, which could be accessed using *pi. To access the next element, increment Pi so that it points to the next element. When we increment a pointer, pointer is incremented by the size of the data type it is pointing to. In this case, since Pi is an integer, Pi will be incremented by the size of an integer. Similarly, if there was a some pointer which is pointed to a character, it would have been incremented by the size of a character, which is 1 byte. For an integer, it will be 2 bytes. For a float, it will be 4 bytes. And for a structure, it is the size of that structure. Now let's try to access an array of user-defined data type like a student structure using a pointer variable. So this is the structure. Student is a list of size n in this program. The program receives the value of n and creates a structure of that size and runs a loop to initialize the information of n students as shown. PTR is a pointer of type student and has been initialized with the base address of the array students. The data members of the first element, such as name, age, branch, can be accessed using the pointer operator. In this case, to access the next element of the structure, PTR is not incremented. Instead, index variable I is incremented every time and added to the base address. I is multiplied by the size of the student structure and then added to the pointer to get the address of the new element. So here PTR is incremented by the size of the student structure every time. Dynamic memory allocation. Whenever we declare a variable, the compiler ensures that few bytes of memory will be allocated to that variable. This is static memory allocation. Now, if you want to allocate a memory space when the program is executing, we make use of dynamic memory allocation. Why is dynamic memory allocation needed? It is essential in programming because it provides flexibility and efficiency in managing memory, especially when the size of the data structure is not known at the compile time. Static memory allocation is often inefficient and even impractical in real-world applications. So let's see some of the functions that could be employed to allocate memory dynamically and free up. Malloc. Malloc allocates a block of memory of specified size. The syntax is void store malloc and the parameter is of type size underscore t. Size underscore t is a system defined type which is of type unsigned int, where size is the number of bytes to allocate and malloc returns the starting address of the allocated memory as a pointer to a void. Now, we can take the return value of malloc and we can typecast it to a pointer of desired type. Malloc does not initialize the memory. The memory allocated by malloc contains garbage values. So it is the responsibility of the programmer to initialize the memory allocated through malloc. Now, calloc. Calloc function is generally used to allocate memory in a contiguous fashion. It allocates memory for a list of objects and initialize them to 0. The syntax is void star calloc with two parameters of type size underscore t. The first parameter is n, that is the number of objects, and the second parameter is the size of each object. Realloc. Realloc is used for reallocation purpose. It resizes an already allocated memory block. It is either used for increasing or decreasing the size of the already allocated memory block. The syntax is void star realloc. The first argument is a pointer to a void which points to the memory already been allocated. And the second argument is the new size of type size underscore t, which specifies the new size which can increase or decrease the already allocated bytes. Free. It is used for freeing up the memory space. It deallocates the previously allocated memory, making it available for future use. The syntax is void free and the parameter is void star ptr. PTR is a pointer that holds the address of the memory to be free. So in order to use all these functions, we need to include the file standardlib.h. Let's write a simple program to understand the usage of these functions. Here, using malloc, we are trying to allocate memory space for one integer and storing the address returned by malloc in a variable ptr1. Using a dereference operator, we are trying to access that memory and store the value 10 there. Next, we are using calloc to allocate memory for 5 integers and storing that address in ptr2. As you can see, calloc receives two arguments. The first argument is the number of integers and the second argument is the size of the integer. Next, using realloc, we are trying to increase the already allocated memory to 10 blocks. So initially, memory was allocated for 5 integers. Now we want to increase that to have memory for 10 integers. So realloc accepts two arguments. One is ptr2, the first argument, which points to already allocated memory, and the second argument is the new size, which specifies whether the already allocated memory size should be increased or decreased. So the return address of realloc is assigned to ptr3. Finally, using free, we are freeing up the space pointed by ptr1 and ptr3. We are not freeing up the space pointed by ptr2 because the realloc function takes care of freeing the space pointed by ptr2. The output of this program is the value stored in ptr1 is 10. This is the value we initialized after allocating memory through malloc. Value stored in ptr2 is 0, 0, 0, 0, 0. So we have 5 integers with initial value of 0 because calloc initializes the memory allocated to 0. Value stored in resized ptr3 is 0, 0, 0, 0, 0 because this memory is allocated by calloc. Have a initial value of 0, whereas the next 5 bytes have garbage values, -1, -12, XX, 00. because this memory is allocated by realloc, which does not initialize it to 0. Complicated declarations. As we all know, we can have an address for both data and functions. Implies we can have a pointer to data and a pointer to function. With this in mind, let's try to understand some complicated declarations of pointers. PA is a pointer to an integer. PB is an array of 3 pointers to an integer. PC is a pointer to an unspecified number of integers. PD is a function without parameters, returning pointer to an integer. PE is an array of unspecified size of pointers to functions. This function has no parameter and each returns an integer. F is a function that returns an integer. FPI is a function that returns a pointer to an integer. PFI is a pointer to a function which accepts nothing and returns an integer. Now let's see the definition of BSD signal. BSD signal receives two arguments. The first argument is an integer and second argument is a pointer to a function that accepts an integer and returns nothing. And BSD signal returns a pointer to a function that accepts an integer and returns nothing. Now, let's see some more definitions. Here fp is declared as a pointer to a function. Int is the return type of the function. And star fp indicates that fp is a pointer to a function. A function func is defined which takes no parameters and returns an int. However, since no return statement is provided, this function implicitly returns 0. The function prints the string hello followed by a /n when called, assigning the function's address to the function point. fp assign func. Here fp is assigned to the address of the function func. The name of the function, in this case func, can be used to refer to the address of the function. So fp assign func makes fp point to the function func, calling the function through the point. This line calls the function using the function pointer fp. The dereferencing *fp is optional because simply calling fp with parenthesis would also work. Both syntax are valid. Next, one more example. Here fp is declared as an array of 10 function pointers. Each element in the array points to a function that takes 2 integer arguments and returns void. This can be broken down as *f of 10 means that f is an array of function pointers. Void is the return type of the function the pointer points to. And int, int indicates that each function takes 2 integer parameters. Func1 is a function that takes 2 int arguments a and b and returns void. It prints the values of a and b, assigning the function to the function pointer. F of 0 assigned func1. Here the first element of the array f of 0 is assigned to the address of the function func1, calling the function via the function pointer. *f of 0 of 1, 2. This line calls the function func1 using the first function pointer in the array f of 10. Alternatively, the function can be called directly with f of 0 of 1, 2, which is functionally equivalent. Function pointers are useful in scenarios where you need dynamic function calls, such as implementing callback functions, state machines, or command patterns. Pointer to pointer. Why is pointer to pointer required? A pointer to pointer is essentially a variable that holds the address of another pointer. This construct is useful in several situations. especially when dealing with multidimensional arrays, dynamic memory allocation, and passing pointers to functions. Key uses like passing two-dimensional arrays to functions, passing of array of strings to functions. A pointer to a pointer is used when you want a function to modify a pointer. Say for example, in dynamic memory allocation, you want a function to allocate dynamically a memory for you. In such situation, you may use a pointer to a pointer. Let's try to understand this through some simple examples. Here, pass the address of an array. Say you have an array of pointers, such as array of strings. ARR is an array of character pointers initialized to value hello world and examples. Hello world and examples are 3 strings. This line declares an array of strings. Each element of the array is a pointer to a string. This is effectively a one-dimensional array of strings, where each string is in turn an array of characters. So this is nothing but a two-dimensional array, in fact. ARR of 0 points to the string hello, ARR of 1 points to the string world, and ARR of 2 points to the string example. Say you want to print this array of strings using a function. Then how the function receives this? Here the function should have an argument, a pointer to a pointer. In main, we can pass ARR, which is an array of pointer to characters, and the number of strings to be printed. To print strings function. Now, let's see the definition of print strings. The function print strings takes 2 arguments. The first argument is pointer to a character called strings. This represents an array of strings. And second argument is count, which is an integer that represents the number of strings to be printed. Here in the for loop, the loop iterates over each string in the array. Strings of I accesses the ith string and prints the string by interpreting strings of I as an null terminated string. So this was one of the use cases where you wanted to pass an array of strings as an argument to a function and display that array of strings in that function. So another use case is to modify the pointer itself within a function. Say when you need a function to modify a pointer itself, you can use a pointer to a pointer. This is often used in situations where you need to allocate memory or modify the pointer address within the function. Now let's try to understand this example. In the function main, the pointer data is initially set to null. This ensures that the pointer is not pointing to any garbage memory before allocation. Memory allocation. Main wants to allocate memory using a function. The allocate memory function is called, and the address of the data pointer ampersand data is passed as an argument to the allocate memory function, along with the number of bytes needed for allocation. If we just pass the data, we can only modify the value the data points to, right? If we pass the address of the data, we can modify the address the data holds. Since we want the data to point to the newly allocated memory, we need to pass the address of the data. So this is what is done here. Inside the allocate memory function, the memory is dynamically allocated for 10 integers. Malloc is used to dynamically allocate memory. The result of malloc is typecasted to an integer pointer to convert the returned void pointer to an integer pointer. The allocated memory address is stored in the pointer ptr, implies the data pointer gets updated to point to the newly allocated memory. After memory is allocated, the main function can use the data pointer to store or manipulate 10 integers. After the allocated memory is no longer needed, it must be freed using the free function to avoid memory leaks. This returns the memory to the system. Hope you liked and enjoyed the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.